All right, these are the density slides, is the density video. So just remember, in the weekly review video, there will be two codes. One will be a written code that will be on the screen, and the other set will be said by myself at some point during the video. And then each code is just three numbers. They're random. You will need all the codes in order to move on with the homework assignment. So remember, when you're writing in the notebook, write what's in green. So a lot of the other stuff is just additional information. If you want to put that in there, great, but everything in green, that'll give you the big broad concepts. You can bullet them. You could write out the whole sentence, but I just take out key phrases and terms so you can get the most amount of information for the least amount of writing. So this is that weekly review video code. I would recommend you write this down somewhere. All right, let's go ahead. Let's get started. We opened up with a game called Will It Float? So you were to guess whether the following items will float or sink in water. So we had an unopened can of Coke, unopened can of Diet Coke, an aluminum cube, aluminum foil, 8-pound bowling ball, a 14-pound bowling ball, a rock, which was pumice, glass marble, metal marble, unopened tomato, soup can, and an anvil. So you were to guess, right, whether they float or sink. We put them in a tank, and some objects floated, some objects did sink. So in order to understand this, we're going to need to understand the concept of density. So if we recall that mass is the measurement of the amount of matter or stuff in an object, and the units is grams. Volume is the measurement of the amount of space a substance takes up, and the units is milliliters or centimeters cubed. Those are the same things. We're going to use milliliters from here on out. Now, 1 milliliter is 1 centimeter cubed. Now, density, the amount of mass per unit volume an object has. So basically, it's a measure of how tightly packed the particles are in that object. And the equation is density equals mass divided by volume. Now, the unit, we just take the unit for mass divided by the unit volume, and we get grams per milliliter. It's also written as grams per centimeter cubed, but we're going to use grams per milliliter. Now, there is this triangle here that you can use in order to use it. Just cover up the variable that you're trying to find out. So if you cover up density, what's left is mass divided by volume. If you're looking for volume, cover up volume, and you have mass divided by density. If you're looking for mass, cover up mass, and you get density times volume. Now, this is just a good representation of what density is. You can see here, density, the one on the right is those particles are more tightly packed. It is more dense than the one on the left. So let's go ahead and just go over an example, like a shopping cart example. So there are 4 shopping carts, all equal size. The more stuff in the cart, the more mass it has. Answer the following questions based on that information. So which shopping cart has the largest volume? Well, I mean, the answer is they all have equal volume. That was in the question. It says there are 4 shopping carts of equal size. They take up the same amount of space. They can hold the same amount of groceries. Now, which shopping cart has the largest mass? So think about which one is harder to push. Which one has more stuff in it? Well, it's going to be the full one, the bottom right one. That has the most stuff. Now, density, right? So we know it's the same volume, and we know that the bottom right is going to have the same stuff per volume because it has more stuff in the same amount of volume. It's going to be more dense. So here's another example that I think will help even further. So if we look at, there are several squares of various sizes which represent their volume. The number of dots inside the squares represent the mass of the object. So you can see here the numbers are written there. Answer the following questions about the squares that follow. So which block has the largest volume? So remember, volume represents how much space it takes up. So if I'm looking at these, block F has the largest volume. Now, which block has the smallest volume? So that's the one that takes up the least amount of size. It's going to be block A. It's the least amount of size. Which 2 blocks have the same volume? So they're the same size. It'd be B and C. Which block has the largest mass? Now, this one's tricky because mass is represented by the number of dots inside each of them. Now, I like to think of it as if these were boxes and those little dots were oranges, which one would be harder to pick up? It'd be the one with the most of them. So if I look at the little guide up here, I know that the answer is going to be E. E has 83 dots. It has the most amount of stuff. It has the most amount of stuff, so it's going to have the most mass. Now, which one has the smallest mass? Well, I look and I see that block B has 5, so it's going to have the smallest. If that was a box of oranges, that would be the easiest to lift up. Now, which two blocks have the same mass? So this one's kind of tricky. You just look up here and you can see here that C has 59 and F has 59. So even though they're not spaced the same, they're not the same size, but they have the same amount of stuff in it. So those are boxes of oranges. They'd be just as heavy to pick up. They'd be just as hard to pick up. Now, which block has the largest density? So that would be the one where they're the most tightly packed. That's going to be block C. Now, which block has the smallest density? We'll look at how far the dots are in them, right? Which one has the least amount? They're the farthest apart. That's going to be block D, is going to have the smallest density. Now, another question that's not on here but can be kind of tricky, which two blocks have the same density? So if I'm looking at this, it's not the number, it's not the size of them, it's the spacing between those dots. And block A and block F, even though block A is smaller and has less dots, those are going to be the same. Those are going to have these same densities because those dots are the same spacing apart. All right. So in order to practice this, we did a class activity in which you're just asked about, what's about density, just to understand the concept of density. So then we can jump into the density calculations. So if we look at a block of aluminum that occupies a volume of 15 milliliters, has a mass of 40.5 grams, what is its density? So what is the problem asking us to find? Well, it's asking us to find density. So what variables do we already know? Well, we're given the volume and the mass. Now, what equation do we use? So if we're looking for density and we know volume and mass, I just cover up density. And I'm left with mass divided by volume. So I get density equals mass divided by volume. And the answer, well, I just take those divided and I get 2.7 grams per milliliter. All right, so let's look at the following problem. Calculate the volume of a liquid with a density of 5.5 grams per milliliter and a mass of 60.5 grams. So what is this problem asking us to find? It's asking us to find the volume. And what variables are known? Well, we know the density and the mass. Those are given to us. So what equation are we going to use? We come over here and we cover up the volume. That's what we're looking for. And it's mass divided by density. So what the answer is, it's going to be 11 milliliters. The last kind of problem you can get, calculate the mass of a liquid with a density of 2.5 grams per milliliter and a volume of 15 milliliters. What is this problem asking us to find? Well, we're asked to find the mass. What variables do we know? Well, we know the density and the volume. So the equation that I use, I come over here and I cover up mass, and I'm left with density times volume. So the answer, 37.5 grams. So we did a class activity to practice this in which you were supposed to, you were going to calculate, do a bunch of calculations about density. So that really helped you understand what density is and helps you calculate it. So now let's answer this question. What determines if an object will float or sink? Just like that opening activity we did, or could an anvil float? So in order to answer this, we did the density lab, the PhET density lab. So this is a simulation in which you are like putting different blocks in the volume to find the mass, to find the volume. This really determines, well, will an object float or sink, and how do we know that? So how do hot air balloons work? So to answer that, all those questions, the one about the anvil, what determines whether an object will float? We know that density is the amount of mass within that certain volume. If an object is placed in a medium, like a liquid or in air, if an object is more dense than the medium, it will sink when placed in that. And if it is less dense than the medium, it's going to float. So the density of water is 1 grams per milliliter. Now, this doesn't have to be water, but it can be water. But like if I put an anvil into, like, so say, liquid mercury, well, that is going to, the liquid mercury, the anvil will float because iron is less dense than the mercury. But also this applies to any medium, like including air. So if you look at hot air balloons, well, the hot air is less dense than the surrounding air, which causes that hot air balloon to rise. That's why helium rises. That's why helium balloons rises, because it's less dense than the air. All right, so we did that lab we did that FET density lab that answered that question. The big question is, what is the Archimedes principle? So now let's take this to the final step and actually do the lab. So when we were measuring volume in the metric system, right, it's the amount of space that an object takes up. The base unit of volume in the metric system is the liter. But we'll be using graduated cylinders with milliliters to measure objects. Now, the two ways to find the volume of an object are going to be to calculate using math or measure using the graduated cylinder. So when we're calculating objects of regular objects, well, you can see here we can use the equation, right? So there are a bunch of equations to these regular objects. In this class, we're just finding the volume for the regular object of a rectangular prism. Real easy. Length times width times height. So if we get this volume or this cube here, 3 times 2 times 3, well, it's going to be 18 centimeters cubed or 18 milliliters. Really easy to do that. Now, if we're using the graduated cylinder, remember, we're looking at the level of the bottom of that meniscus. So this doesn't happen too much in the plastic ones. More happens with the glass or those smaller graduated cylinders, but you do have to take into account for that. So if we're measuring the volume of an irregular object, we measure through something called displacement. So we can measure the volume of an irregular object using displacement. The key here, 1 centimeter cubed equals 1 milliliter. So if we look at this and we put 50 milliliters of water in a graduated cylinder, right? So that's the starting volume. But then I place the key in there. I want to find the volume of the key through displacement. Well, now the level is 60 milliliters or 60 centimeters cubed. Now the volume of the key, it displaced 10 milliliters of water. So that was when we did the Eureka Density Lab. And I'm going to go ahead and give you the verbal code. The verbal code is 176. I say that again. The verbal code is 176. So in the Eureka Density Lab, what we did was we did what Archimedes did. So Archimedes was tasked with finding out whether a goldsmith ripped off the king when the king gave gold coins to the smith and said, I want a crown made out of this. And the goldsmith came back with the crown, and the king wanted to make sure that he was not getting ripped off. And so the king went to Archimedes and said, well, how can you figure this out? And that's when he came up with this displacement to figure out, hey, if I know the mass of the crown and I know the displacement, I can calculate the density, and it must have the density of gold. If it doesn't have the density of gold, that goldsmith ripped them off. So once again, this is the density video, and as always, there is too much unknown in the universe to take a break from learning. Get out there and question everything.